All right, everybody, this is learning how to draw Lewis structures. Okay, so some of you guys have done this before. I'm going to walk through how to do this and then show you an example, and then I'm going to turn you guys loose to practice some on your own. Okay, so Lewis dot structures. This is a way to draw molecular compounds. Okay. We don't typically do this for ionic compounds because they're not sharing electrons, they're sort of transferring, so they're not actually bonded, right? So drawing Lewis structures, we're trying to show how these things are bonded, okay? So I'm going to walk through the steps, and like I said, give you an example, and then you guys can try some, okay? So the first thing that you want to do is count the total valence of all atoms in the compound. Okay, we're going to count the total valence of all atoms in the compound. All right? So what does that mean? What does valence mean? All right? Valence means outermost electrons. Okay? So let's walk through, let's do water. That's the easiest one to do. Okay? So here's our example. We want to count the total valence. So how many electrons does hydrogen have in its outermost energy level? Well, it's in energy level 1, and it only has 1 electron. So we're going to get 1 electron from hydrogen. There's a second hydrogen that we're also going to get 1 electron from. And then oxygen. We got to find oxygen. So find oxygen on your periodic table. It's all the way over here, number 8. It is in column 6, right? 1, 2, 3, 4, 5, 6, right? Row 2, energy level 2, number 6. So it has 6 valence electrons, which means our total valence of all atoms in the compound is 8. So this is sort of like law of conservation of matter, okay? You cannot create or destroy electrons, so 8 electrons is what we have to work with to make this structure valid, okay? Okay, the second thing you're going to do is put one atom in the center and others around it. How do we choose which one goes in the center? The one with the least electronegativity is in the middle. Okay? So the one with the least electronegativity is in the middle. There is one exception to this. Okay? The exception is hydrogen. I'm going to tell you why. So hydrogen would always be the least electronegative, just in terms of the trend. The problem is hydrogen can never be kind of like a central atom because hydrogen can only take one bond, right? So hydrogen only has space for 1 electron. It's in energy level 1. It has no access to p or d or f orbitals, so it can't take more than that. So hydrogen's actually happy with just 1 bond. So it's the least electronegative goes in the middle unless hydrogen is there, and then we'd go to the next least electronegative atom. So if that's the case, we're going to say that, right? We're going to put oxygen in the middle and the waters surrounding it. Okay, so that's the next part. Third part, connect all atoms with a bond. Okay? I'll just put that in quotes because a bond is considered 2 electrons. You can think about it as 1 from each of the atoms. Okay? So I'm going to connect all of the atoms with a bond. So I'm just going to put 2 electrons in between, 2 electrons in between. So right now I've used 4 electrons total, and I need to use 4 more. So that's the first thing. We're just going to connect them all. This is called sometimes called the skeleton structure because it's just basically the outline of what's connected to what, sort of like the backbone of the molecule. Okay. Next thing, fill in the outer atoms with the extra electrons to satisfy what's called the octet rule. Okay? So the octet rule basically says that atoms strive to have 8 electrons in their outermost shell. Octet rule. Again, the one exception being hydrogen. It's often referred to as the duet exception because hydrogen can only take 2 electrons there. Okay, so we're going to fill in the outer atoms with the extra electrons to satisfy the octet rule or the duet rule. Okay, so let's look at hydrogen. This hydrogen is already full because it thinks it has 2 already because these are being shared. So this hydrogen is good. Now we'll go to this hydrogen over here. 1, 2. This hydrogen is good. So we don't need to do anything else for this step. If they were not full and I had more electrons, I would add them. Okay, last step. Put any excess electrons around the central atom. Okay. This is a valid Lewis structure if we check 2 things. So we're going to check total electron count, make sure we use the right amount, and that we are satisfying the octet rule for everyone. Okay, so that's the idea. We're going to check the total electron count, that we are satisfying the octet rule for everyone. So let's try it. So here we have our water. I have 4 more electrons to do, so I'm going to now put them around the central atom. Okay, and then I'm going to double check. I used 8 electrons. Check. Hydrogen is happy. Hydrogen is happy. Oxygen is happy because it looks like it has 8. Double check. Okay, so this in fact is the structure for water. Okay, now here's the tricky part. Last one. If you follow the steps and don't have enough electrons to make everyone happy, share more. In other words, double or even triple bonds. So I'll show you one of those, and then you guys can try some of these on your own. So here's an example. So let's do carbon dioxide. Okay, so if you want to try it on your own first, you can. Just stop the video and try it on your own. If you still need help, then we'll walk through it together. So step 1, all right, go back up to your steps. Step 1, count total valence. So let's do that. Count total valence. Carbon is in group 4. Oxygen is in group 6, but there's 2 of them. So 6 times 2 is 12, plus 4 is 16. So this equals 16 electrons that I must use. Okay? Next thing we do, choose an atom to go in the center. We're going to choose the least electronegative. Remember, electronegativity's trend is up to the right. So that's going to put carbon in the middle and the oxygens around it. Okay? Then what do? We connect them with a bond. As you get better at this, you can use a line instead of 2 dots. Just understand that every line represents 2 electrons, not 1. Okay. Okay, so now we start going around the exterior atoms to satisfy the octet. This oxygen needs 6 more, like this, right? This oxygen also needs 6 more. but I've used 16 now, right? 2, 4, 6, 8, 10, 12, 14, 16. I've used 16 electrons. Okay? So I already used them all. So now you got to ask yourself the questions, right? Did I use 16? Yep. Is everyone happy? Well, oxygen, good. Oxygen, good. Carbon, not so good. Carbon only has 4 electrons around it. So this is not a valid structure, but I don't have any more electrons to put on the carbon. So that comes down to our final step. If you follow all the steps and you don't have enough to make everyone happy, share more. So that's what we're going to do. I'm going to take these 2 that oxygen has on its own, and I'm going to put them in the middle. So that's going to make me have 4 in between the carbon there, and I still have these around the oxygen. And then I'm going to keep going with what I had over here. There we go. So I didn't add any more electrons, I just decided to share more. So now what do we have? Well, this oxygen still has 8, right? It has 4 of its own and 4 in the middle. It's good. This oxygen we didn't change at all, still good. The carbon now has 6. Better, but not perfect. So we got to do it again. So I'm going to take these, and I'm going to dump them in the middle. And so now we're going to end up with double bonds on both sides. Here. Double check, ask your 2 questions. Did we use our 16 electrons? 2, 4, 6, 8, 10, 12, 14, 16. We did. 16 electrons are good. And now is everyone happy? Oxygen has 8. Carbon now has 8. Oxygen has 8. We are good. So this is in fact carbon dioxide. We can simplify this now using lines. Right? So as you get better and you understand what the lines are, there we go. Okay? So that's carbon dioxide. Okay? So follow the rules. I'm going to post about 5 or 6 of these, give them a shot, and we'll see how you do. All right? Have a